Hi 10. So in this video, we're going through the solutions in exercise 802, okay, where we deal with inverse variations. Okay, remember if two variables are inversely related, all right, if x and y are inversely related, we can immediately write this equation, x is equal to k over y. Okay, so don't get this confused with direct variation. Okay, it's a different equation that you get at the end. Now, question 1 was already covered in another video, so you need to look at that if you would like to have a look at the solution for that. But I'm going to start with question 2 here, which says the rate of vibration of a string varies inversely as its length. Okay, so we're told that the vibration rate varies inversely with its length. All right, so we have these two variables, okay, which are inversely related. So we can write that equation down. V is equal to K over the second variable, which is L. Okay. In our second sentence, it says a string that is 8 centimeter long vibrates at that many hertz. So 8 centimeters is the length of the string, and that must be the rate. Okay, so let's call that V. All right, so that's a specific condition that we can substitute into my general equation here. And so V 9375 is equal to K over L, which is 8. Okay, and I can solve for K by multiplying 8 on both sides. That will eliminate the 8 at the bottom, and that will give us K is 8 times, so 8 times 9375, which is that number, so 75,000. So my specific equation is V is equal to 75,000 over L. Okay, my actual question is what length of string will vibrate at that many hertz? Okay, so we're finding out what L is when V is that. Okay, so let's substitute that into our equation. Okay, so V, what is, so we know what V is. It's 6250 is equal to 75,000 over L. Now, if you remember our lesson on solving these type of equations, there's a quick shortcut to solving for L here. Okay, and that is switching the L and the number on the other side of the equation. All right, but if you do not know why that's the case, I'm going to show you the proper logical step to solving for L. Okay, so what we need to do, okay, we need to make sure the L is in the numerator. All right, we can do that first by multiplying both sides by the L at the bottom. Okay, because if I do that, the L goes away in the denominator. All right, and I'm left over with 6,250 L. Okay, and then my next step would be to divide out the number in front of the L, which is 6250, divided by 6250 on that side too, and that'll give me my L, right? So that would be 75,000 divided by 6250, which is 12. Okay, so my answer is the length of the string must be 12 centimeters to vibrate at 6,250 hertz. So my answer would be C in this question. So if you're getting the hang of these solutions involving variation, right? Let's have a look at the next question. The temperature T in degrees Celsius of the air varies inversely with the height, okay, above sea level. At 150 meters above sea level, the temperature is 30, okay, and so H is 150 when T is 30 degrees. Okay, so we can even write down our general equation using that information. All right, so we can start off with T is inversely related to H, K over H. All right, and then we can substitute in the exact values. When T is 30, H is 150. All right, and then we can go on and solve for K by multiplying out the denominator. Okay, that will give me K is equal to 150 times 30. which is 4,500. And so T is equal to 4,500 over H. Okay, let's answer our question here. What is the temperature at 300 meters above sea level? Okay, so it's asking us, what is T? What is T when H is 300? What is T when H is 300? All right, so let's substitute that into the equation. T is equal to 4,500 over H. Okay, in this case, we're told H is 300, so that goes in the bottom. So 4,500 over 300, that's 15. So the temperature would be 15 degrees Celsius. So that was part I. Part 2, part I, we have H now being 2,500. So that's the number that I'll be substituting to my equation. So T is equal to 4,500 over 2,500. Okay, that will obviously give me a different number. Divided by 2,500, which is 1.8 degrees Celsius. All right, let's have a look at question B. Now in this case, we want to find out what the height is above sea level when we're given specific temperatures. So we're given T is 8 degrees Celsius for part I. All right, so that's what I'll be substituting T with to find out what H is. Okay, so my equation was T is equal to 4,500 over H. All right, T is 8 degrees in I, so that's what I'll write down for T, and then solve for H. All right, and the trick here to solve for H is swatching the denominator with that number there. Okay, so H is equal to 4,500 over 8, and that will be my value for H, which is 562.5, and our unit is given here. Okay, it needs to be in meters. All right, part 2 is the same thing. You just replace the T in that question with the given T there, which is 22.5. Question 4. Okay, so in this case, the number of people who attend a concert varies inversely with the amount of space allocated to each person. If 80 square centimeters is allowed per person, the ground can hold 3,400 people. How many people could attend the concert if only 60 square meters was allocated per person? So let's have a look at the two variables that we are dealing with here. So we have the number of people, let's call that N, who attend a concert varies inversely with the amount of space that you have. So let's call that A for area. Okay, so using that first sentence, I can write down the relationship in equation form. N is equal to K over A. All right. The second sentence gives me the specific conditions. All right. If A is 80, okay, we have 3,400 people. And so I substitute that in, equals to K over 80. All right. And to make K the subject, I just need to multiply by 80. So K is equal to, let's get our calculator out, 80 times 3,400, which is that number there. Okay, so your specific equation is N is equal to 272,000 over A. Now we want to find out what N is, how many people could attend if the amount of space allocated to each person, the A, is 60. All right, so we're substituting in the value of A into our equation and finding N. So N is equal to 272,000, as per our equation earlier, over 60, okay, which will give me the answer to that question. So 272,000 over 60, which is that number, so 4533.333 to be exact. Okay, let's answer our question. So our question is asking us how many people, right, could attend this concert, right? So we're finding the number of people, right? We can't have 0.3333 of a person, right? So we've got to round it down. Okay, so my approximate answer would be 4,533 people. Okay, so guys, you need to always go back to your context, all right, and answer your question in that context, all right. So now in our example here, our answer had to be the number of people. We cannot have a part of a person, and so we've got to make this answer the most reasonable answer by rounding it down to the nearest whole number. Okay, question 11. So in question 11, we are told that the amount of time it takes Sarah to move house is inversely proportional to the number of friends there are to help her. Okay, so the amount of time, let's call that variable t, okay, is inversely proportional to the number of friends. Let's call that n. Okay, so we can even write that first general expression down. Equation down. So t is equal to inversely proportional, so k over n. All right, let's see if we have any specific conditions. When she has 4 friends helping, the job takes 3 3/4 of an hour. So when n is 4, t is 3 3/4. Okay, so that's what we will substitute into my general equation here. So 3 3/4 is equal to k over 4. All right, and you solve for k by multiplying out the 4. Okay, that will give us k is equal to, all right, let's get our calculator out. So 3 3/4 is 3.75 times 4, which gives us 15. Therefore, t is equal to 15 over n. All right, let's answer the first question here. How long will it take if she has 6 friends helping? So 6 friends is 6n. If n is 6, what is t? Is what the question is asking us to find. So let's substitute the value for n into our equation. So t is equal to 15 over 6, okay, which is 15 divided by 6, and that's 2.5. It's 2.5 hours according to my context here. Part B, how many friends must she have to move the house in 3 hours? So if t is equal to 3, what must n be is the question. Okay, so let's substitute in the correct values into my equation. So here we know what the t is, it's 3, is equal to 15 over n. All right, and remember the trick to solving for n, when the n is in the denominator, we can switch with the number on the other side of the equation. Okay, that gives me n is equal to 15 over 3, which is 5. So she needs 5 people to help her move the house in 3 hours. So we can even write that as an out. So we can say therefore Sarah needs 5 people to move the house in 3 hours. Okay, so again we answered our question in our context using correct units. All right, so to wrap this up, if you have tracked through the video from the beginning, you'll be able to see a pattern where we first write down the general equation using the 2 variables that are given to us in the question. Okay, and then you find what k is to find the specific equation using the given specific values for the 2 variables. Okay, and then after that you just needed to substitute in the correct variables to solve your problems. And then lastly, you go back to the context of your question and answer your question in that context.